you can send the messages to the co-host. Okay, audible. So yeah. And did anyone of you tried this magic square problem? Like, did you looked into it, how it can be done, the possibilities of it? Or, okay. How was the weekend for everyone, first of all? Like, yes, so let's start with a different question today. How was the weekend for everyone? You all can answer it freely. It can be a completely resting day. It can be something adventurous. Okay, Bhuvnesh is saying it's still going on. Okay, great. How about you? Mine was all the resting phase. So, okay. Tomorrow too. Yeah, tomorrow is the holiday, right? Okay, what about others? Still the energy down? It was the weekend, guys. I can understand the weekdays are hectic, but what about the weekends?
Actually, I'm very feeling down. Like probably my family has COVID.
Okay, got it. Don't take much tension of it because these days, I guess the vaccination has worked good, like in a good way. So, yep, they are all gonna be okay. Like, Vishnu, are they with you or like they live somewhere else?
Yeah, no, they live in the we live in the same house.
Okay, so you are safe from that thing, right?
Even I'm having little bit of
Okay, okay, no issues, no issues.
yeah. We
Perfect
have
stuff.
one room. In one room, everyone stays like that.
Where do you stay, by the way? You say like you are
Al
from America, right?
yeah, Albany, New York.
Albany, New York. Okay, so there is just one room where all of your family people stay, is it?
I mean, we have some rooms, but living room is one, so
Oh,
everyone is.
got it, got it. Take
Yeah.
care of your health and your family members, and yeah, stay safe. Okay, I'll be explaining the question once again since it was the weekend. So there is a very high chances that you all must have forgot it. So the question is, you have been given a 3 by 3 matrix. Okay. And this 3 by 3 matrix, you have to convert it to a magic square. Now, what is the definition of a magic square? The magic square definition is at any point, you take the sum of any row, any column, and any diagonal, their sum should be same. Okay. So like, let's suppose this was your current row. If I take the sum of this, it will be 2 plus 8, 10, 10 plus 5, 15. If I take the sum for the first column, it will be 2 plus 1, 3, 3 plus 4, 7. So column sum is 7 and row sum is 15. That means it is not a magic square. Clear? To convert this to a magic square, we just formed a magic square which was like 276. If we add them all, we will be getting it as 15. Same thing goes with the column. If I add all the numbers in the column, 2 plus 9, 11, 11 plus 4, 15. You can take this column as well, 7 plus 5, 12, 12 plus 3, 15. You take the diagonal, 2 plus 5, like 7, 7 plus 8, 15. So this is a magic square. Even if you will add the numbers over in this particular matrix, this is also a magic square. Okay. Now our question was, you need not only convert to a magic square, there can be multiple possibilities of like 3 by 3 matrix to be a magic square. So we need to figure out what is the minimum cost needed to convert like a normal 3 by 3 matrix to a magic square. Is it clear? I will come what is the cost, but right now what I'm explaining is you need to convert to a magic square and you need to find out a magic square which requires minimum cost. Now, what is the cost? In every cell, like you can see this first cell and the first cell in the normal matrix, the absolute difference, if I say absolute difference, it means that no matter if the value you are getting is negative or positive, you just need to consider the value. So 8 minus 2, that was 6. Then similarly, I figured out the difference between all and I got the sum as 24. Okay, so this was your sum. If I figured out the difference for this next magic square, I got the sum as 26. Which one is lesser? 24. So this should be your answer as per the current scenario. Clear? So this is what the complete question is. And now we need to figure out how can we do this. You will only be given this particular matrix as an input. Everyone clear? Yes. Okay. So now my next question is, obviously you all had a good weekend. Any one of you, being the nerd, tried this question? Yes. Okay. So any observation you figured out? Anything you got out of it? Gaurav, are you saying yes? Because I was waiting for the answer. Okay. So the easiest way to do it is you have been given a 3 by 3 matrix, and at every point you can't just like keep on iterating in a matrix. It is slightly complicated. So the first part which you can do over here is convert your 3 by 3 matrix to an array. Does anyone know how to convert a matrix to an array? Obviously, you know, in the matrix, there are like 3 by 3 elements, which makes it equals to 9. So you will be having 9 elements in your array. Anyone knows how to convert the matrix to an array? No, we will see it. It's simple. Your matrix is 2, 8, 5. Next is 1, 3, 7. And next is 4, 9, 6. If you have to convert it to an array, it's simple. Like try to add elements one by one to the array. What I will do here is Vishnu, don't you think this is a 2D array only? A matrix is nothing but a 2D array.
Yeah, that is true. But when we are declaring as array of 9, then it is one dimension. If we have to put comma something like that, 3 comma 3 will be a 2-dimensional array.
Here we are not talking syntactically, we are talking logically right now. That how
Okay.
to convert. We are not writing any code as of now. Okay.
Okay, got it.
Okay, I have one block extra. I'll just remove it. So if it is like 285, I'll just straightforwardly keep my 285 here. Then 137. So 137 will come. And after that 496. So 4, 9, and 6. And you're done. So this is how we are converting. Now we need to find some relation. Okay. Oops. How we need to find the relation? If I'll see here, it is like this is your 0, 0 element. This is your 0, 1 element. This is your 0, 2 element. This is 1, 0. This is 1, 1. And this is 1, 2. This is 2, 0, 2, 1, and 2, 2. So your 0, 0 element is now converted to 0. 0, 1 is at first position. 0, 2 is at second position. Are you all getting this? That is, I'm basically trying to tell you all about the rows and columns. So if you want to find the sum of rows, it will be continuous. That is 0, 1, and 2. If you find the sum of elements at 0, 1, and 2, you will be getting your row sum. Or you will be adding the elements at 3, 4, 5, you will be getting the sum of another row. Or if you will be adding the elements at 6, 7, 8, you will be getting the sum of a different row. Clear? So finding the row sum is not difficult in the 1D array. Clear or not? Yes. Now talking about the column sum. Column sum is nothing but this, the element which is at 0, 0, the element which is at 1, 0, which is nothing but at third position. Now let me take another. Which is at third position, and at 2, 0, which is nothing but at sixth position. So 1, then 3, like 0, then 3, and then 6. So you can also figure out the column sum very easily because it is at difference of 3, 3. Then coming to the diagonal, it is like the element at 0. Next is at 1, 1, which is nothing but 4. And the last element, which is at 8. So you can figure out here also the diagonal sum 0 to 4 and 4 to 8. Clear, everyone? For the row sum, there is no difference in the indexes, like they are adjacent to each other with the difference of 1, 1 in the indexes. In terms of column, they are at a distance of 3, 3, like there is a gap of 3, 3 elements. And in terms of diagonals, there is a gap of 4 elements. I hope you all can relate and find the relation as well. Yes. Okay. Okay, Vishnu, no worries. Everyone, I hope you all are clear. And can you all convert this 2D array into a 1D array now? Yes, good. So I am expecting the code from your end. Will you all be doing that? Okay. Now you all know that we need to figure out all the permutations for a 3 by 3 matrix so that we can figure out that which permutation gives us the magic square and which permutation do not. That is our sole purpose, right? So those who all uses Python or any other language, they can figure out the permutation library in their own like language choice. Okay, like there is some library in the Python. You can like put some condition. I'm not writing the entire code. Here you can take an array, and this array will be filled with your next permutation library, which is a library in Python. Sorry, permutation, not permission. In this case, you just need to check if magic square, you will write some function to check if the given array is a magic square or not. Okay, so I'm passing the array in the magic square function. If it is returning true, that means it is a magic square. Then in that case, you need to calculate the answer, which is nothing but minimum of your current answer and the cost of just a minute. Cost of your array with respect to the original array. I'm not sure. Like this is your current array and this is your resulting array. You need to find the difference between them, and that will be stored in the answer. Closed bracket and closed bracket. So you need not worry about what this next permutation function is doing. It's simply like it is fetching you all the type of permutation which will be generated, and one by one you will just check if it is a magic square, find out the minimum cost, and at the end return your answer. Clear to all? How many of you are from, like, are using Python as their language? Okay, Aman is using. Aman, you can try writing the code using this. Okay. And the remaining people in Java, this library is not there. So obviously you need to write the code manually, and for that you need to write the code for permutation. Everyone, are you getting this? Okay. So anyone has any idea how can we find the permutation part? Do you all want time for thinking how can you find the permutation, or should I just directly jump onto the code? No responses. What happened, guys? Let's write the code. Okay. For that, we will first understand the permutation part, like how permutations are actually generated. For that, I will be taking the example of a 2 by 2 matrix so that the permutations can be easily generated here. Let's imagine you have a Your first permutation is itself 1, 2, 3, and 4. The next it can possibly be 1, 2, 4, 3. The next is 1, 3, 2, 4. Next is 1, 3, 4, 2. Next 1, 4, 3, 2. Next can be 1, 4, 2, 3. These were the permutations where I kept 1 as the first number. Okay. Having 1 as the first number, I'll be having total 6 permutations. Now we will see with 2. With 2, it's like 2, 1, 3, 4. Next is 2, 1, 4, 3. Next is 2, 3, 1, 4. Next is 2, 3, 4, 1. Correct. Next is 2, 4, 3, 1. And next is 2, 4, 1, 3. Clear, everyone? You can see we are keeping one of the number as constant. Just a minute. And then we are switching between the three numbers. Okay, we are finding the permutation between the three numbers. How we are finding the permutation between three numbers? At every point, we are fixing one of the number and switching between the two. So we are getting two permutations for the fixed second number. Then we fixed 3 over here, then again got the two permutations. Then fixed 4, again got 2. Same thing is gonna happen with, like it has happened with 1, it has happened with 2, it will happen with 3, as well as it will happen with 4. Are you able to get this? Hence, what will happen, you can say you got from here 6, you got from here 6, the coming one 6 again, and the next also coming one you will be getting 6. Adding all the permutations up, you will be getting it as 24, which is nothing but 4 factorial. Correct. Clear to all? So if you will be finding for, let's suppose, 3 by 3 matrix, which is nothing but 9 numbers, 9 factorial, can anyone tell me the result for this? Calculate it quickly and tell me the result. It will be somewhere around 362,880. Like it's a huge number, which you are gonna like traverse on all the permutations and see if it is a magic square or not. Clear to all? Yes. Okay. So while I was traversing, did anyone got any thought how it can be done? If not, we will see it. We are having a function void permutations. Let's suppose I'm taking here. Why I have taken the void? Because it is just doing the task of generating the permutations and nothing else. Clear? Okay, so just a minute. What we will be having over here, we'll be having over here as our integer array. This array you can assume as an empty array, and we are trying to fill in this array to get our magic square. Okay, so this is an empty array of like length equals to 9, and we are trying to fill it. Next is, every time when you are filling up an array, you should always make sure that every number you have filled should not be repeated, right? Like if you have filled 1 in your array, it should not be repeated again. For that, you need to take a Boolean array taken, which will keep a track of which number is taken already and which number is still not taken. So accordingly, you can fill in your array. Next is, you should be having an index variable which will keep track of that, if like which index you are currently in and which index you're gonna fill next. Other than this, any other parameter you all feel like that we should be having? As of now, let's just start with this. So our main task is to fill the array from 1 to 9. Okay. For this, I will be starting my loop from 1. It will continue till 9. And here you need to check if taken of I is equal false. If it is false, then only you can proceed. So as soon as you get in, you have to take care of taken of I equals to true now. That means the number is taken. Next, you need to fill your array of index with your current value I, and that's it, right? You are done with the filling of your current array element. Now you have to take care of like filling up the remaining array. For that case, you need to call your solve function. Sorry, not the solve function, it is permutation this time. You need to call your permutation function over here. Pass the array as it is. Index will be index plus 1. And your taken array. That's it. Anything you all feel like that I should do more in this? Base case, okay, that still has to be written. Anything else? What is the base case, by the way? Can anyone help me with the base case, what it can be? If index is equal array dot length, we need to return. No, if index is equal array dot length, or you can say 9, and it should not be array dot length also. Who has written this? Kishan, because you're slowly filling your array. You don't have an array which is like completely filled and you are keeping it as your base case. Your base case should be that your complete array is filled. That is the length of your array, which is nothing but 9. Index is equal 9. In that case, you need to check if your current filled array is a magic square or not. So you need to check it here. If you need to write a magic square function, you need to pass your array here, and then you need to check if it is equal true. Just give 2 minutes. I don't know why the screen is stuck. Okay. And here, if it is coming out as true, you need to update your answer, and your answer is answer equals to minimum of. You need to pass your current answer, and then you can write a cost function over here in which you can pass your current array. You don't have your main array over here. You can take that as you can consider that as you can say or class level variable. So from there you can fetch its value, or you can take it over here as well. I'm taking it here to avoid the confusion. Int I'm writing it as MAR, main array, and you can pass your MAR. You can find the cost, and then whatever answer it will return, compare it with the current answer. If it is the smaller, then that is going to be your answer. Clear? And take this answer variable as a global value so that you need not worry about the returning and all. If you want, you can take it as a like local value as well, no worries. But if you will take it as a global value, then this return will be void. One thing that you all didn't thought of is this taken like this taken array will be at some point be completely true, right? It will be the point where your complete array is filled. Everyone getting me? Now you know that you need to find several other combinations as well. Like this taken array gets true for just one combination, and you need to consider all the other combinations as well. Are you all getting it? So as soon as this permutation function is being called and like it goes into the permutation loop, after that you just make this taken loop or the taken of I as false. Okay, so what it will do when once you are done with your array thing, slowly, like what it will do, it will start making all the other numbers as false. And at the end, it will be ready for the other permutation as well. Clear? Okay. Yes. Now, did you got this question? Or you have lots of questions? Guys, why are you so silent? Only I can see Gaurav and Kishan, sometimes Bhuvnesh responding, and the remaining people are all silent. Aman also responds sometime, but what about the remaining guys? Did you got this question? Okay, after running, we'll get it properly. Okay. So when you're gonna run it, it's on the hacker rank. You can search with magic square problem, you will be getting it. What about the remaining people? You still have to write on your own the magic square function, which I have still not told you all. You have to write the cost function, which still I have not told you, and they are very easy. If I'm telling about magic square function, it's nothing but you need to find the sum of rows, sum of column, sum of diagonal. If all of them are equal, then it is a magic square. So it's not that of a problem. If I'm talking about the cost function, you know how to find like the difference between the rows, columns, and the diagonals, and then add them all. So it's not a tough function. So I'm expecting you all to write these two functions on your own. Clear, everyone? So except Kishan or and Bhuvnesh, others, do you have any questions? Okay. I guess I am too good at explaining magic square because no one is having any questions as of now. Anyone wants its analyzation, like how the array is getting formed, how every permutation is getting formed, or are you good with that? Analyzation needed. Okay. We'll look into it right now, just for the first time. Like we'll see for the two array formation. Okay, so initially when this function will start, you know that this permutation function, I'm just like writing it as PER, you will be having an empty array. Then you will be having a taken Boolean taken array, which will be having all its value as of false. Then index will be at 0. Then your main array will be like there. Okay, I'm just writing it as M. It will check if index is equal 9, but index is 0. Not true. It will directly jump onto the for loop. In the for loop, your I will be 1. Okay. I is 1. It will check if taken of 1 is equal false. Is it false? Yes. It will enter in here. I'll just make the so now it will make taken of I equals to true. Okay. Array of index equals to I. So from where is your I starting from? 1. So your array of index that is 0 will become 1. Clear? Everyone clear so far? Next, it is again calling the permutation function. So this particular one line statement will be in our recursive stack now. Okay, just consider there is one function, like there is something remaining over here. Now this is called.
Excuse me.
Yep.
Here, like inside for, we have written if taken of I. Here it should be index, right?
Y index.
For the very first time, I is equal to 1, right?
Mhm.
But we are storing it in 0th position.
Yeah, so index is only taking care of our positioning, not whether the number is taken or not. Like index has nothing to do with the whether the number is taken or what is the number. It is just filling up your array.
So let me like tell you, if taken of I is equal to false, that means taken of 1 is equal to false we are searching for.
Correct.
And taken of I we are making it true for index 0.
Index 0 has nothing to do over here. We are just filling the number in the index of 0. Okay. It
When we
has
are filling,
nothing.
that's what I'm asking. Like taken of 1 is equal to true, we are filling at index 0 how?
So the solution for that is just ignore here the 0th position and consider from 1 till 9 numbers. That is, make your taken array of
That's
10 numbers. Okay. Yeah. Thank you for correcting that. Everyone, are you clear with this? Okay. So when permutations function is again called, what will happen? Again, it will check if index is equal 9, which is still false because index has now become 1. It will again come to the for loop. From where your I is starting, 1 only, right? Now it will check if taken of I is equal false. Is it false now? No. So this won't enter over in this if condition. It will go straight forward to the incrementing this for loop. And now your I will become I will now become 2. Now it will check if taken of 2 is equal false. Is it false? Yes. Now it will make it as true. And what it will do, it will fill your array of index, which is nothing but 1. Index is equals to 1. So array of 1 will be filled with value 2. Clear? Again, this will be called the permutation function with value 3. So with index value as 2, it will check if 2 is equal 9. Is it equal? No. Again, it will enter this for loop. It will check for I equals to 1, which is like If it is false, it is not. It will again check for I equals to 2. If it is false, it is again not false. At the end, it will check for I equals to 3. It will find out that yes, it is false. Just give me a minute. So for 3, again, it will find out that yes, it is false. So it will fill 3 in your array. Everyone, are you getting this? This, it will make it as true. And here 3 will be filled. Okay. So similarly, you can imagine that 4, 5, 6, 7, 8 will be filled up. And at one point, this entire taken array will be true. Clear? Everyone, are you clear with this first permutation? Now, when it will, for the last time, it will check if index is equal 9. This time it will get it as true. It will check if like it is a magic square or not, and it will update the answer accordingly. Okay, like this is something which will taken care by our two different functions. We need not take care of it right now. Once this part is done, from here you need to return. Return in the sense it will return to this specific function call, which you can say the function call with 8. Okay, because for 9 we returned the value, so it will return to 8. For that, it will see if taken of I is equal false. That is taken of 9 is equal false, not 8, 9. Equal false. Sorry, my bad. It will execute this statement and it will change the value of 9 to false. Yeah, my bad. Sorry. I was saying it was checking. It won't check. It will directly execute it and change its value to false. Clear to everyone? Yes. For this particular true value, or you can say 9, now what it will do, it is getting executed for the previous statement, right? Sorry. This something I missed. Just give me a minute. Yep. For this particular, when this value will return after executing your if condition, I index equal 9, when it will return, it will call back to the recursive stack where your index value was 8. Okay. So it will change taken of I equals to false. Your I was here 9. So it will change its value to false. Now this for loop is still not completed. So it will go up and execute the for loop. What will happen in this scenario? Your I was 9 already. I plus plus will happen and now your I will become 10. Is 10 less than or equals to 9? Guys, are you getting? No. So this complete for loop is executed now, and it will complete the last function call. Are you clear now? That means the recursive stack which was remaining for this last value, it is executed completely. Clear? Now what it will do, it will jump to the next recursive stack. That is for 8. Just a minute. When it will jump to this just give me a minute. Let me see what's the battery. Okay. For this recursive stack, when it will jump, it will make taken of I equals to false, which is again this 8th position. Like for in the taken array at the 8th index, it will be made as false. Now again this for loop will continue executing. I value was 8 here. I plus plus will make it 9. Are you getting this? Yes. It will come in here, and now it will check if taken of I is equal false, which is taken of 9 is equal false. Is it true, the if condition? Yes. It will come in again, and now it will make taken of I, which is the 9th index, as true, and array of index, which was nothing here but the 7th index, it will make it here as 9. Are you guys getting that? That is, at the 7th index, you will be getting the value as 9. And this 9 will stay here as it is. Clear to all? Okay. Now, again, this permutation function will be called. Array will be called as it is. Index plus 1, that means your index was here 8. 8 plus 1, that is, sorry, index was 7. 7 plus 1, 8 will be called. Now it will check if 8 is equal 9. Is it equal? No. Again, it will come into this for loop. Again, the same thing will continue for 1 till 8th index. Okay. Up to the 8th index, it will find out that all the values are true as of now. When it will enter for I equals to 9, it will find out that it is false. Are you getting this? Now what will happen? It will make taken of I equals to true, which is like this particular index again as true. And here your array of index will be filled with I. What will be done here? Sorry, this was already made true. For this, it will come for 8th value. This will be made as true. And at this particular index, it will be 8. I have messed it up a little bit as of now, but did you guys got it? And if not, I will again explain this particular solution tomorrow if you still have the doubts, because like right now I can understand it is too messed up. So yeah, what's the feedback? Did you got it, or do you want me to explain it once again? Confused. Will be good if we have a revision. No worries. Today, as per I have explained you all, just try to do it. Otherwise, I'll be explaining it's like the entire procedure tomorrow, that how the things are going in. Okay. So we'll see it tomorrow as well. No worries, because like this question is little important for recursion and backtracking. So we will see it. And yeah, tomorrow is the last session for recursion. There is like 1 or 2 questions more, which I would like to tell you all. And after that, we will move on to linked list. Clear to everyone? So today I'll be sharing the questions. Okay, so guys, please on your end, try to like go through its analysis. And tomorrow also, when I'll be explaining you, you will be getting it in a better way. Clear? Okay then, so thank you for attending the session. I'll see you all tomorrow. Bye-bye. Please, yeah, I'll share the questions too. You are talking about the magic square problem, Bhuvnesh, or you're talking about the recursive problems? Okay, queues, yeah, sorry. Okay. So bye everyone. We'll see you tomorrow. Bye bye.